Hello everyone, how are you all? And let me know how was your FA one exam went. Okay, obviously today was your physics paper, most of you. I hope that is there. Just let me wait for some second till I can hear myself in this audio so that I can start my class. Yeah. Okay. So I hope I am clearly audible today, unlike yesterday, last time when there was some issue happened with my audio. Today, I hope that is clearly audible to all of you. Just give me a moment. So today, I am going to discuss with our ACE series. Now, you might be thinking, sir, our exams are going on. Why you are taking ACE series? Yes, exams are going on, but you have to look for your future as well. And for your future, obviously, ACE is something that is going to help you in the long term. So do not miss out on that. And if you are joining me for live, obviously, I want to know how was your FA1 paper? Was it easy? How many questions did you get common from throughout my marathon sessions and also early 30-minute revision that I did today morning? So let me know in the comment section below. And today's session, we are going to discuss electric current 25 PYQs from the previous year papers, including 2026. Each and every year, almost 5 to 6 questions come from this chapter alone. So this is the most important chapter of entire second PUC. And just give me a second. Yeah. So let's start. Which now this question in 2026 based on the experiment that you are going to perform. But yes, this is a question based on current electricity. So that's why I have added it. So in 2026 there was 5 question directly from the chapter and 1 question from experiment based on the same chapter. Okay, which of the following circuits is correct for verification of Ohm's law? Now if you see that almost all of them look similar. So how to identify? First of all, you have to remember in Ohm's law we use an ammeter and a voltmeter. Ammeter is a device which is used to measure current. Voltmeter is a device which is used to measure voltage, right? And ammeter is connected in series in the circuit so that all the currents can pass through the ammeter, and voltmeter is connected across the resistance only so that so here you can see the resistance. So voltmeter is connected across the resistance so that you can measure the voltage across the resistor. Now which of the following configuration is correct? So if you see here, voltmeter is connected in series, which is wrong, and ammeter is connected in parallel, that is also wrong. So these two are wrong. So these two are wrong, either this one or that one. Now both of them almost look similar, but if you observe them carefully, you will see that plus minus minus plus, plus minus plus minus. So there is a change in the symbol of the plus and minus, and based on that you actually have to identify which of them is correct. Now remember, this is a battery, so battery means this is plus, this is minus. So the current should pass through the ammeter such that always every device should be aligned with this plus and minus symbol. So if this is plus, this is minus, so in the order plus minus should follow, and that's why this is correct answer. The option 2 is correct answer for this question, because this is plus, this is minus, this is plus, this is minus. So current is flowing in this direction from the battery. So the device should also, all the device connected in the circuit should also align itself along with the direction of the current. Okay. Okay. Now let's move on. Okay. Now next question, question number 2. In the figure, the values of current I1, I2 and I3 respectively are. So if you see the figure, they have given some currents and they are asking you what is the value of currents I1, I2, I3. This is a direct application of Kirchhoff's current law. This is an application of Kirchhoff's current law, or we call it junction rule. So junction rule means we have to apply the law at each and every junction to figure out the currents. So here we have 3 different junctions. Junction number 1 here, junction number 2 over here, and junction number 3 over here. Okay, from these 3 junctions we have to identify what is the current through each and every junction. So if you recall the concept of Kirchhoff's current law, it says that whatever current is going into a junction and whatever current is going out of the junction, that should be same. So if say I1 and I2 are going in and I3 and I4 coming out, then Kirchhoff's junction rule says that I1 plus I2 should be equals to I3 plus I4. Now it's not necessarily that 2 is going in, so only 2 has to come out. No, not necessarily. 2 can go in, 1 can come out, or 3 can go in, 2 can come out. So any number of combination in input and output can be there, but you have to remember input current should always be output current, and this is direct consequence of conservation of charges. Okay, charges are conserved, so whatever charge is going into the junction, same amount of current should come out of the junction as well. So charge has to be conserved, so that's why this is correct. Now let's move on and analyze this circuit. If you see that here 5 ampere is going in here, I1 current is exiting. So is in this junction 1, 5 ampere going in, I1 coming out. What else? If you trace back, you will find that through this junction, this way, another 1 ampere is coming out as well. So total input current in this junction is 5 ampere and output current is 1 ampere given, and I1 is not given. So what will be the value of I1? I1 will be 5 minus 1, that is 4 ampere. So I1 will be 4 ampere. Now let us move on to the junction number 2. So in this junction, if you see, I1 current is going in. I1 current is going in, and if you see through this 1.5 ampere current is coming out. 1.5 ampere is coming out, and in the bottom direction we have another current which is not given, which is mentioned only as I2. We have to figure out I2. Again 4 ampere going in, 1.5 ampere coming out, I2 coming out. So I2 will be 4 minus 1.5, that is 2.5 ampere. So 2.5 ampere is this current. Now 2.5 ampere calculated. Now let us move on to the third junction. In the third junction, 2.5 ampere is coming in, right? 2.5 ampere is coming in this direction, and if you see here we have a current output as 1.5 ampere, and remaining current is passing through I3. So what will be the value of I3? I3 will be 2.5 minus 1.5, which is equals to 1 ampere. Easy question, right? Just by looking into the diagram you will be able to solve this question. So not a difficult question. So let's mark the answer. So if you see, answer is 4 ampere, 2.5 ampere, 1 ampere. So 4 ampere, 2.5 ampere and 1 ampere. So correct answer is option C. Okay. There is one more option almost similar except this 2 ampere thing. So make sure when you are calculating, make sure you double check your calculation once more so that you do not miss out on such easy questions. These easy questions are actually backbone of scoring well in KCET. Okay, the question is easy. You might feel little confused initially by looking into the diagram. Oh, I will not be able to solve circuit diagram based questions. Not all circuit diagram based questions are difficult, but if you put some time into it, you will be able to solve. Okay, most of the circuit diagram based questions in KCET are solvable except few of them which requires you need to know some tricks. We will definitely teach you that trick as well. Anyway, let's move on. The number of electrons moving per second through the filament of a lamp of 60 watt operating at 120 volt is. Charge of an electron is given. Now the power rating is given and the voltage is given. Okay, they are asking you the number of electrons moving per second. So basically first step is to find the current. Once you can calculate the current, what is current? Current is given by charge divided by time. So if you make time equals to 1 second, okay, then current will be equals to the charge, and then we will use our quantization principle of charges, Q is equal to NE, and we will be able to solve this question. So let's try to simplify it. So power is given, we know that power is given by voltage into current. P is equal to VI. Okay, Vodafone Idea is power. Okay, Vodafone Idea is power. Just to remember, just to memorize, or just to recall something, you can remember it like this. Okay, so voltage is given 120 volt, power is given 60. So what is the current? Current will be 60 upon 120, that is 1 by 2 ampere. So this is the current. So current is calculated. Now we have to find the charge. Now how can you calculate the charge? There are two ways. First of all, a current is calculated. So in 1 second, the amount of charge that will be flowing is half coulomb. Okay, in 1 second, the amount of charge that will be flowing is half coulomb. Okay, now again, as I mentioned, either you use Q is equal to NE, number of electrons you have to find, N you have to find. So N equals to Q upon E. This is one way to calculate. Okay, but this method is good when the charge is a multiplier of 1.6. There is a shortcut way to solve as well. What is that shortcut way? You have to remember 1 coulomb charge is equal to number of charges, number of electrons is 6.25 into 10 to the power of 18. 10 to the power of 18. If you remember this value, the problem is very easy for you to solve, specifically this kind of questions. Okay, if it is asking you about quantization problem, many cases they will give you 1.6, 3.2, 4.8. In that case, you take the charge of the charge of an electron, put it here, cancel it, simplify it, done. But here, if you are because you are not allowed to use a calculator, half divided by 3.2 can be little bit tricky for you to simplify. So if you remember that shortcut, that you have to multiply 6.2 into 10 to the power of 18, that is approximate value, and the charge is given by half. That's it. Okay, so here basically 1 coulomb charge is this many electrons. Okay, so if you remember this, that will be lifesaver. You don't need to put the value of charge, you don't need to put anything, only the charge value, that because it is 1 coulomb for this much, so half coulomb, it will be half into this value, right? So that's what we are doing. So it will be 3.1 into 10 to the power 18. This is applicable when the charge is not a multiplier of 1.6. Specifically, when the charge is not a multiplier of 1.6, you can directly use the, whenever charge is known, you calculate using 6.2 into 10 to the power 18, multiply with the charge, you get directly the value of the number of charges. So it will be 3.1 into 10 to the power 18. So option C is correct answer for this case. If you are using the Q by U formula, you might stumble upon this and you might think this is the correct answer, which is wrong. So make sure for different horses for courses, for different types of questions, you have to use different types of methods as well. Right, now let's move on with the next question. Given below are two statements. Statement number 1, the resistivity of a conductor is independent of its temperature, which is not correct statement. Resistivity of a conductor does depend on temperature, and if it is a conductor, if temperature increases, resistivity also increases. The resistivity of a semiconductor decreases with increase in temperature. Select the correct option. Okay, this is the question. So obviously resistivity of conductors increases with increase in temperature, whereas resistivity of semiconductors decreases with increase in temperature. semiconductors are exactly opposite to that of the conductors. So statement number 1 is wrong. Okay, statement number 1 is wrong, but statement number 2 is correct, right? So statement 1 is false, statement 2 is true, so option D is correct. So read the all the statements correctly. Both statements are false, both statement 1 and 2 are true, statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true. Okay, so make sure you read all the options and accordingly you answer your question. Okay, next question number 5. Current flowing through a wire decreases linearly from 10 ampere to 0 in 4 seconds as shown in the graph. Find the total charge flowing through the wire in the given time interval. So here I versus T, current versus time graph is given, and they are asking how much charge has been flown. Okay, amount of charge that has flown through the conductor. Now this kind of question is unique. Obviously for this you need to know that when you are plotting I versus T graph, okay, the area under I versus T graph gives you the charge. Okay, charge is the area under the graph, the IT graph. Okay, so this is the fact that you need to know, otherwise you will not be able to solve it. So when you are given a I versus T graph, you just need to calculate the area. Now if you see that here it's a triangle, so area under the graph will be Q into half I max into T max. Okay, so what is I max? I max here in the graph it is given 10. Okay, so 10, and time max is given 4 seconds, because starting from 10 it goes to 0 in 4 seconds. So basically maximum current was 10 and the time required for the current to come 0 is 4 seconds. So just put these values and you will get your answer. So 2 to the 4 and 20 coulomb. So correct answer for this is 20 coulomb. Okay, so correct answer for this question is 20 coulomb. Now let's move on, and as I mentioned, if you are watching live, please mention in the comment section how was your FM1. Okay, and if you have any doubts regarding any questions, also feel free to ask me in the chat down below. Now this is also a very interesting question. A conducting region 10 to the power 19 electrons and 10 to the power 19 protons move to the left, while 10 to the power 19 alpha particles move to the right per second. The resulting electric current is. Very interesting question. So here we have 10 to the power 19 electrons and 10 to the power 19 protons move to the left. Okay, so here suppose this is a conductor. Okay, we have 10 to the power 19 electrons and 10 to the power of 19 protons. They are moving towards the left. Okay, and 10 to the power 19 alpha particle moving towards the right. So what is the resulting electric current? This is happening per second. Okay, this is happening per second. So you don't need to worry about it. You just find the charge, that is net charge, which is moving in a particular direction, and based on that you can calculate the current. Current is charge by time. So obviously charge, if you calculate, time is given per second, so T is equal to 1. So you can directly calculate the current, right? Now if you read the question carefully, here you will see the on the left we have electrons and protons in equal number. Okay, 10 to the power 19 electrons and 10 to the power 19 protons. So equal number of protons and electron, they are moving towards the left. That means they are combined effect will be 0. Their combined effect towards the left will be 0, whereas their combined effect on the right their combined effect on the right should be there. Now alpha particle, for that you need to know about alpha particle. This is slightly mixed question with the concept of different chapter. This chapter we have not dealt with, but alpha particle, you may have learned it in your chemistry chapter, is basically a doubly positive helium ion. Okay, it's a doubly positive helium ion. So if you take 2 electrons out of helium, that is alpha particle. So the amount of charge that is associated with doubly positive helium ion is given by 2 into 10 to the power of 19. Okay, this is the number of helium, and this is the charge per helium. And what is the charge of alpha particle? Charge is obviously, for one single charge, it is 1.6 into 10 to the power of minus 19. Okay, so this is the total charge that is flowing, and which direction it is flowing? It is flowing only towards the right. Okay, so right side, right direction, positive charges are moving. Left side, positive negative, they are moving in equal numbers, so they will cancel each other. So 10 to the power 19, 10 to the power of minus 19, they cancelled, and we get 3.2 coulomb charge per second. That means current is equal to 3.2 ampere only. Okay, and the direction is obviously right, because left side everything cancelled out. Okay, so it will be 3.2 ampere towards right. Okay, now give me a moment. I am going to show you something very, very interesting. So right now you can get access to our free YouTube batch, and it is absolutely free, distraction free. Now, if you come to YouTube, there will be a lot of other distractions to you. But if you want to learn without any distraction, definitely, and also a lot more than you can whatever you can get in YouTube. Also the lecture notes, assignments, etc. If you want to get that, you have to come visit in the lecture. Go down there, you click on the join free ACE KCET 2027. Now click on this link, and once you click over here, you will be redirected to this page. Once you click come to this page, click on buy now option. It is absolutely free of cost, you don't need to do anything. Once you click on there, okay, you have to register for the first time. Once the registration process is done, next time onwards you just need to put the OTP, and from that OTP you can log in. And once you have logged in, you will get the access to our free YouTube batch. Physics, maths and biology are there for now. Obviously chemistry will be added very, very soon. And once you go into the course, you will see that all the lectures are listed over here. You go down, and you will get all the lectures, whatever series that we are doing in our channel will be available over here. You can get the class notes as well. Okay, and assignments are going to be added very, very soon. Assignments will also be added very, very soon. Okay, you can check on the slides also, you can get the notes. Everything will be at one place, all the notes, everything will be added over here. Okay, and this is a one platform that you need to consider. You don't need to go anywhere else, and it is completely distraction free, because obviously, as I mentioned, in YouTube there will be a lot of distractions. But if you visit this page, one page where all the subjects are listed, and the how to access it, you have to click on join free KCET 2027 course now. Click on this link, it is given in the description section of this video. Once you click there, you will get the access for this batch. Okay, now let's move on with our lecture. Next question from 2025. So 2026, as you can see, there was total 27 questions that was asked. Now, in the following circuit, the terminal voltage across the cell is. So here there is a cell is given, and they are asking what is the terminal voltage. Now, if you see this diagram, terminal voltage means what? So here this resistance is actually the internal resistance. This is small r. Okay, this is the EMF of the cell E. Terminal voltage means voltage across this. So either you calculate the voltage across this 3.9 ohm, or you calculate the voltage across this assembly of internal resistance and EMF source. Both way you will get the same answer. Now, how to do that? That is the main question. For that, first step is to calculate the current flowing in the circuit. Okay, how to find the current? So only two resistors are there. So total resistance or equivalent resistance, you might say, is given by the external resistance plus internal resistance, which is 3.9 plus 0.1, that is 4 ohm. And the EMF of the cell is 2 volt. So what is the current? Current is very simply the EMF divided by total resistance, that is 4, not 4, 2 divided by 4, that is half ampere. So this is the current that is flowing in the circuit. Now there are two ways to calculate this terminal voltage. One, as I mentioned, you just directly multiply the current with the external resistance and you calculate the voltage, which is V is equal to IR. I is half, and this is 3.9, so it will be approximately 1.5, 1.95. Okay, 1.95 voltage. This is one way to do it. Okay, this is the answer. Another way that you can do is by using the EMF. So V is equal to capital E minus IR. This way also you will get the same answer. Okay, capital E minus capital I into small r. That is also will give you same 1.95 volt as well. Okay, so there are two ways, as I mentioned. Any way you can follow the answer, but you will always get the same answer. So no need to worry. Okay, and I always do not recommend to remember all the formulas. Try to basic. This is a basic question. You can solve it using basic problems as well. So use the basic things. Right, now let's move on with the next question. Two cells of EMFs E1 and E2 and internal resistances R1 and R2, E2 greater than E1 and R2 greater than R1 respectively, are connected in parallel as shown in the figure. The equivalent EMF of the combination is E equivalent. Then which of the following is correct? Now this is a tricky question if you don't know how to solve it, because no data is given, no values are given. Then how to solve it? But from the diagram it appears to be they are connected in parallel combination, right? A and B are the two junctions, and between these two cells are connected. So definitely this is a parallel combination of the cells. Now how to handle this kind of question, the easiest way, because it's a data-less question, we have to use the data on our own. Okay, so let us take E1 to be 1 volt and R1 to be 1 ohm. Smallest possible values, based on our convenience we can take, as long as this condition is satisfied. As long as this condition is satisfied. E2 is greater than E1, so let's take this as 2 volt and R2 also 2 ohm. Okay, we are taking the same values obviously, so that our mathematical calculation is less. So in such cases you take some assumed values, obviously as small as possible, but convenient, 1 2 3 4 like those numbers, and the basic condition given in the question must be satisfied. Here E2 is mentioned greater than E1, so we have taken E2 as 2, E1 as 1. Okay, and R1 as 1, R2 as 2. Now, what is the formula for equivalent EMF? Okay, basically all the questions are based on equivalent EMF. If you read the question, equivalent EMF greater than E2, less than E1, between these two and nearer to E1, between these two and nearer to E2. So obviously either C or D will be correct. Both of them look similar. So let's see what will be the correct answer. So equivalent EMF when cells are connected in parallel combination is given by E1 upon R1 plus E2 upon R2 divided by 1 by R1 plus 1 by R2. This is much easier formula to remember than whatever mentioned in your textbook. If you remember that formula, that also can be used, but this is, in my opinion, is easier to remember and use. Okay, so E1 was 1, R1 was 1, E2 was 2, R2 is 2, divided by 1 by 1 plus 1 by 2. So in the top we get 1 plus 1 divided by 3 by 2. So 2 divided by 3 by 2, that is 4 by 3. Okay, so this will be 4 by 3. So 4 by 3 means 1.33 volt. So definitely the final value of voltage is between 1 and 2. So final value of voltage is between 1 and 2. Now with which it is more closer? So it is nearer to E1 or nearer to E2. That's what we have to figure it out. So if you see that, what is the difference between E equivalent and E1? So E equivalent minus E1 is 1.33 minus 1, that is 0.33. And E2 minus E equivalent, obviously E2 is bigger, so that will be 2 minus 1.33, that is 0.67. So who is nearer? Obviously E1 is nearer, because the difference between E1 and E equivalent is smaller. So definitely it is nearer to E1. And even though we have used 1 and 2 values, even you can use any other value, you will always get the same result, that the final EMF is between these two values, and there it will always be nearer to the smallest possible value. Okay, if this condition is satisfied, E2 is greater than E1, R2 is greater than R1, then this will be always the case, no matter whatever value you choose, right? Let's move on with the next question. This is very interesting question. If you don't know the trick, you will either guess the answer, or you have to scratch your head in the exam. Okay, or you will just write the equation and then you will try to figure out. So better than that, always use some assumed values to solve this kind of tricky questions. Now, the variation of resistivity rho with absolute temperature T for three different materials X, Y and Z are shown in the graph below. I did identify the materials X, Y, Z. So let's see what are all the materials. Semiconductor, nichrome, copper. So there are three different kinds of material are mentioned. Semiconductor, obviously semiconductors, nichromes are alloys, and copper is a good conductor. Now, if you increase the temperature of a good conductor, its resistivity increases. So, if you increase the temperature, resistivity increases. So, X, this one, okay, X definitely represents the conductor. Okay, the X value definitely represents conductor, because its resistivity is increasing. This is the increasing graph. So, X must be copper. Okay. X must be copper. Now what about other two? For semiconductors, as you increase the temperature, its resistivity decreases. Okay, resistivity decreases, it becomes a better conductor. So resistivity decreases for a semiconductor. So definitely Z represents semiconductor. What about Y then? That must be a alloy. This must be alloy, so it will be nichrome. Okay, it must be nichrome. Now one point from this question, important information: for alloys like nichrome, manganese, etc., the resistivity remains almost constant, even though you see it is increasing, but the increase is very small compared to increase in the resistivity of a conductor. Okay, in the same time, conductor's resistivity goes very high, whereas for a semiconductor, resistivity decreases very low. For a alloy like nichrome, manganese, etc., their resistivity remains almost constant. The variation is very small, and that's why we use this kind of wires in standard resistance. What is standard resistance? In future, when you are doing lab experiments based on say resistance boxes, so whenever you use a resistance box, inside the resistance box there are some resistances used. Okay, and those resistances are called standard resistance, and in those cases standard resistances are made using alloys such as nichrome or manganese. Okay, so definitely, because their even the temperature of the room increases, say in the winter time, someone performing the experiment at 20 degrees Celsius, and in the summer at 40 degrees Celsius, the same experiment is being performed, the result should not vary too much. That's why for standard resistances always alloys are used, not nothing else. Okay, so X is a conductor, copper, Y is nichrome, and Z is semiconductor. So correct answer is option C. Correct answer here is option C. X is copper, Y is nichrome, and Z is semiconductors. Right? Now let's move on with the next question. Given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of the wire? Current and drift speed, current only, current, electric field and drift speed only. Okay, so let's see. So if the area is not uniform, suppose this is a wire. Here this is an example of non-uniform wire. So you see that here the area is small, here area is large. Okay, suppose this is area A, this is area B. Okay, now drift speed is almost same as continuity equation that you studied in your PU1, and in my lecture also I told you that if you multiply drift speed along with the area, that is a constant quantity. So drift speed into area is constant. Here also same thing. Okay, equals to VB into B. So as area increases, drift speed decreases. Okay, as area reduces, drift speed increases. Okay, so smaller the area, higher drift speed, higher area, smaller drift speed, so that multiplication between drift speed and area remains constant. So if the uniform cross section is not uniform, then only electric current is constant. Only electric current is constant, nothing else. Everything else is subject to change. So current only, current only. Now why not electric field? First of all, in this option along with electric field, drift speed is also mentioned. So as I mentioned, drift speed is not constant, so you can ignore it. But electric field is also dependent on the width of the conductor. That's why in shorter region, electric field will be little stronger. In broader area, when the surface area is more, drift speed will be electric field will be slightly weaker. So electric field and drift speed almost go hand in hand. But electric current is constant. Current is given by NEAVD. Now this quantity is constant. A into VD is a constant. Now obviously number density for a given material at a temperature is constant. Charge of an electron is always constant. Right? So these things are constant. So that's why current is constant. Current can be only changed if you change the voltage. Okay, if you change the voltage, if you change the material, then only current will be changed. If the material is same, voltage is fixed, current will always remain constant. Okay, now let's move on with the next question. The graph between variation of resistance of a metal wire as a function of its diameter, keeping other parameters like length and temperature constant is. So, resistance of a metal wire. So, resistance of a metal wire is given by R is equal to rho L upon A. Okay, rho L upon A. Now, where is the diameter? So, they are asking you that diameter is changing and how resistance is dependent on diameter. So, where is the diameter? So, length and resistivity are constant. So, material is fixed, temperature is fixed, so resistivity is fixed, length is fixed here also. So, we can say that resistance is directly proportional to 1 upon A. Okay, inversely proportional to area. Now, we know that area of a circular diameter is given by pi r square. Here r is radius. Okay, and if you replace it with the diameter, you get pi d by 2 whole square or pi by 4 d square. Now, this is also a constant. That means we can write resistance is inversely proportional to square of the diameter. So, resistance is inversely proportional to square of the diameter. So, inverse proportionality graph is only one of them, and that is this one. This is the inverse proportionality graph. So, that means correct answer is option 2. Easy question, just the formatting of the question is slightly different than previous questions. So, in KCET, it is considered to be a direct question, even though you need to do a small understanding. But if you understand that resistance is inversely proportional to area. Hello, dost. Hi. So, and one very important point to remember about all over KCET exam, in many cases, if you are not able to figure out the question, I generally give this advice to students just before exam, but I am giving you right now as well. Okay, if you are not able to figure out the pattern of the graph, okay, remember, if there is a pattern like this, if there is a pattern like this, inverse square or normal inverse graph, there is a 80% chance based on historical evidence, 80% chance this will be the correct graph. Okay, because in KCET there are multiple graph based questions, and 80% of those cases the correct answer turns out to be this kind of pattern. Okay, so in case if you have to take a blind guess, you do not have a time to solve the question and it is a graph based question, you want to take a blind guess, you should put your bet on this. There is a 20% chance it will be wrong as well, but 80% chance it will be correct. Okay, so that's why I say this is the favorite pattern of KCET. Okay, this graph pattern, right? Now let's move on with the next question. E is the electric field inside a conductor whose material has a conductivity sigma and resistivity rho. The current density inside the conductor is J. The correct form of Ohm's law is. So, the alternate form or correct form of Ohm's law is J equals to sigma E. Now, if you see in the each and every option, this option is not mentioned. Instead, they have mentioned E is equal to sigma J, J is equal to rho E is equal to rho J, E dot J is equal to rho. So, they have given every option other than this. So, how to figure it out? So, let's try to find out what is E. Obviously, this is not correct. Okay, this is also not correct. Possibly this or this can be correct. So, let's find out what is E. E is equal to J upon sigma. E is equal to J upon sigma. Now, 1 upon sigma is resistivity. So, it will be rho J. Okay, resistivity is 1 by sigma and conductivity is 1 by rho. Okay, they are inverse of each other. So, if conductivity is high, resistivity is low. If resistivity is low, conductivity is high. Same like that, right? So, definitely correct answer is this one. E is equal to rho J. So, just they have changed the format. They can be asked ABC also. There was one year there was a question based on that same concept. instead of giving EJ, they have given ABC, and they have asked you what is the identify one of them. Okay, so that also is possible. Now, this is another very important pattern that I ask you to remember. Okay, this pattern, remember this weird kind of complex kind of structure. Okay, in the circuit shown, the end A is at V0 potential and B is grounded. The electric current indicated in the circuit is. So you have to find the electric current that is indicated in the circuit. Now this might looks like, sir, this is neither parallel nor series. How to solve this? Is this 3R series? These two are parallel like that? Remember, this is a very specific pattern, and this pattern is our very favorite Wheatstone bridge pattern. Okay, in Wheatstone bridge, how do we draw? There is a galvanometer. Generally, in galvanometer, if you replace it using a resistor, it looks like this. This is the point. This is another point. Okay, and here this is the another resistance. This is another resistance. This is the Wheatstone bridge pattern. Now, if you draw it little carefully, okay, so that this is your starting line, this is your starting line, okay, this is your middle line, and then this is your ending line. Okay, in between these two are drawn like this. Okay, so basically if you imagine that you just put it like this, you take these 2 points and just a second, I don't know what happened. If you take these 2 points and just rotate it, if you take these 2 points and rotate it, you will get the same pattern back. Okay, that is our Wheatstone bridge pattern, right? Just a second. So if you take these 2 points and rotate it, you will get your Wheatstone bridge pattern back, and that this pattern is nothing but a Wheatstone bridge pattern. Okay, so that means we have to find out whether the bridge is balanced or not. Obviously, it will be given to you as a balanced condition only. You don't need to worry about it as well. So if you see, this is R, this is R. You can, this is the galvanometer. So initially, while doing it, you ignore this resistance. R by R equals to R by R. Obviously, R by R is 1. R by R is also 1. So both sides of the Wheatstone bridge, what is the balanced condition? P upon Q equals to R by S. Okay, so if you take the ratio of these two and ratio of these two, if the ratios are same, then we say that Wheatstone bridge is balanced condition. Now, what is the important point when the Wheatstone bridge is in balanced condition? When the Wheatstone bridge is in balanced condition, there is no current that passes through the galvanometer, right? So no current passing through the galvanometer means this is actually not contributing at all. This part is actually ineffective in this circuit. So if this part is ineffective in this circuit, what we need to do? We just need to erase it. This is not playing any part in this overall thing. Okay, you just need to erase it. Now, if you look into the circuit, you will see that here we have a resistance, another resistance in series. Here also one resistance, another resistance in series, and their overall combination is connected in parallel. So if you imagine the Wheatstone bridge, okay, if you imagine the Wheatstone bridge, and imagine that through the galvanometer no current is passing. So no current passing means you can simply erase it, right? And you will say this is basically my circuit now. Okay, this is my supply. So these two are in series, these two are in series, and they are parallel to each other. So R plus R, you will get 2R. Okay, and R plus R, this will also be 2R, and they are connected in parallel combination. Okay, they are connected in parallel combination. So the entire complicated looking circuit comes down to this. Okay, now what is the equivalent resistance of this? The equivalent resistance is 2R into 2R divided by 2R plus 2R, right? R1 R2 divided by R1 plus R2. So it will be 4R square divided by 4R. So R cancels, 4 cancels, and you get, so this entire thing is turning out to be only R. Okay, so this complicated looking circuit have only a resistance of R. Okay, now using the same logic, second circuit, you do not need to do any mathematical calculation. Using the same logic, you just say this is also 2R, 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 everything is 2R. That means this is also a Wheatstone bridge. So there is no current passing through this one. So we can erase the galvanometer here as well. And 2R, 2R, everything is in, these two are in series and these two are in parallel. So that means the equivalent resistance here will be equals to 2R. Okay, how do I do that? Because in this case every resistance was R and their equivalent resistance turns out to be R only. So here every resistance is 2R, so their equivalent resistance should also be 2R. So what is the total resistance? For total resistance, obviously you have to add them. So total resistance it is equal to 3R. So 3R is the resistance. The voltage is V0. Here it is grounded 0. So current will be potential difference divided by total resistance, that is V0 by 3R. Okay, if this side is not grounded, some other voltage is there, then you have to find the voltage difference. Okay, so it will be V0 upon 3R. Very interesting, important pattern to remember, and this pattern can be repeated in your exam as well. Right, now let's move on with the next question. Another important question, and based on this same question, there was a question in 2026, this same question. The electric current flowing through a given conductor varies with time as shown in the graph below. The number of free electrons which flow through a given cross section in the conductor in the time interval 0 less than 20 seconds. So number of electrons you have to find. So 0 less than 20 means up to this. So 0 to 20. So this is the 20 end. So basically up to this much, how many electrons flow. So if you remember, I told you that if you calculate the area under the graph, you get the charge. So area under the graph gives you the charge, and then you use the quantization formula or the shortcut formula that I told you, any one of them, to calculate the number of electrons. Let's see. First, obviously, you have to calculate the area. Now, if you see, this area is obviously looks little complicated. How to calculate? So, if you see, this is a trapezium. Now, it is a time for you to remember the area of a trapezium. Do not divide it into rectangle and triangle. Yes, that is also you can do it, but that is a waste of time. You can directly calculate the area of a trapezium using a single formula. So, if you are not aware of it, I will teach you, and you have to remember it, because from now on you are no longer in first PU, so you have to use certain shortcuts while doing calculations. So here this is the area under the graph. Okay, this is for this portion, and this is another area. This is also a second area. This is a rectangle. So this rectangle's area we can calculate, okay, easily. First we will calculate this area, say area 1. So what is area 1 and what is area 2? So area 1 is a trapezium. So trapezium area is area 1. Even though I am drawing it like a triangle, let's see like this, area 1. So for a trapezium, the area is given by half into sum of the parallel sides. Sum of the parallel sides into the distance. So what is the distance? Here this is the distance. Okay, sum of the parallel sides into the distance between them gives you the area of a trapezium. Now if you see the diagram, okay, these values are missing. Okay, this values, so this is the one length. So this is A. This say B. Okay, this say B. Now how to find this A and B? So if you look into the graph, A and B's values are missing. So if you see here, it is starting from 0, it is going to 200. This is the midpoint of 200 and 0. So this must be 100. okay, and it is in milliampere. Similarly, this is 200, this is 400, this is the midpoint of 200 and 400, so this must be 300. So not always everything will be explicitly given in the graph. You may need to use your a little bit of understanding to figure out the values. Okay, so this is 300, this is 100. So for this it will be 100, for B it will be 300. Now everything is in milliampere, so whatever we calculate will come out to be in millicoulomb. So final charge will be coming out to be millicoulomb. Anyway, let's see the area of this. So half into 100 plus 300 into the distance is 0 to 10. This is ending at 10. So 10 value we will take 10. Okay, 5 to the 10. So it will be 400 into 5, that is 2000. Okay, now what about area 2? Second area is easy. Area 2 is this one, which is simply a rectangle. So for it, area will be 10 into 300. So this is the distance. So 10 to 20, 10 to 20 distance is 10, and this is length is 300. So it will be 300 into 20, that will be 6000. Okay, so total charge is addition of these two. Total charge is addition of these two, that is area under the IT graph. Area under IT graph. So this will be 6000 plus 2000, that is 8000 millicoulomb. Why milli? Because the current here is given in milliampere. So be careful about it. Now millicoulomb means it will be 8000 into 10 to the power of minus 3 coulomb, or 8 coulomb. Okay, it will be 8 coulomb. Have I made any mistake? Let me check once more. (300 into 10). Okay. Sorry. I made a mistake here. So this will be 10, not 20. This will be 10. So 300 into 10 will be 3000. Okay, so this will not 6000, this will be 3000. And it will be 5000, not 8000. And it will be 5 coulomb. Okay, this will be 5 coulomb. Now 5 coulomb is okay. Now what? How to calculate the charge, to number of electrons? So again, I will use the shortcut that I told you. What shortcut we are going to use here? The shortcut is, always remember, the number of charge is given by 6.25 into 10 to the power of 18 into the charge. This is the shortcut. This way you can calculate the number of electrons, number of charged particles. 6.25 into 10 to the power of 18 into charge. Here charge is given as 5 coulomb. So put that value over here. So N will come out to be 6.25 into 10 to the power of 18 into 5. So it will be 5 6 is 13. 13.15. So 31.5 into 10 to the power of 18, or sorry, 32.5 into 10 to the power 18, or 3.25 into 10 to the power of 18. 3.25 into 10 to the power 18. This is the number of electrons. 19. 32, right? So one decimal we have reduced. So 3.25 into 10 to the power 19. These many electrons are flowing. So if you read the option, it will be correct answer is 3.125. They have done exact multiplication. Okay, 3.125 into 10 to the power 19. So this will be the answer for this question, right? Now let's move on. with the next question. The IV graph for a conductor at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, is as shown in the figure. The temperature coefficient of resistance of the conductor is about. So here basically in the graph, two different temperatures, 100 and 400, they have shown you. Okay, and the angles are mentioned over here. I hope that is visible. So angle for so obviously lower temperature means current will be higher. So this is 100, angle is 45. So angle is 45 degrees. And for 400, okay, this is 30 degrees. Okay, and this is a I versus V graph. I versus V graph is given over here. Okay, they are asking you the temperature coefficient of resistance. So how to calculate temperature coefficient of resistance? So that is very important part to remember. Temperature coefficient of resistance can be calculated using the simple formula that RT equals to R naught into 1 plus alpha T, when this R naught is measured at 0 degrees Celsius. R naught is resistance at 0 degrees Celsius. But obviously here 0 degrees Celsius is not given, 100 degree and 400 degrees Celsius is given. So let's figure out. So suppose this is RT1, this temperature difference is T1, alpha T1. Okay, and another temperature RT2 is R naught 1 plus alpha T2. Okay, so how to simplify it? We are trying to find the alpha's value. So if you divide both sides, you get RT1 by RT2 equals to 1 plus alpha T1 by 1 plus alpha T2. Again, this is not very easy to simplify. So either you can do the cross multiplication or the okay, let's do the cross multiplication. I think that will be easier. So do the cross multiplication, you will get RT1 plus alpha RT1 into T2 equals to RT2 plus RT2 T1 into alpha. Okay, so alpha's values you take in one side and remaining quantities remain on the other side. So you get RT2. Obviously at temperature higher it is bigger. So RT2 minus RT1, RT2 minus RT1 equals to alpha into RT1 into T2 minus RT2 into T1. So alpha value equals to RT2 minus RT1 divided by RT1 T2 minus RT2 T1. Okay, this is the formula that you can remember and you can carry it with you in the formula sheet. Okay, not in the exam hall, but yes, you can keep it in your formula sheet, this formula. Okay, now this formula, using this formula you have to use it. Obviously this is not so easy. This formula you have to remember to solve it, and from the graph first thing you have to figure out how to find the resistances. Okay, so if you take a small slope of this graph, delta y and delta v, okay, resistance is given by delta v by delta I. Delta v by delta I, v is equal to IR, right? So if you take the slope of the graph, basically slope is given by, what is the slope of a graph? Slope of a straight line. If you have done that in the mathematics class, slope of a straight line, it's slightly geometry is there. Slope of a straight line is given by m equals to delta y upon delta x. Here delta y is I and delta x is v. Okay, so this is slope and that can be calculated using tan theta. But resistance on the other hand is given by delta v by delta I, that is 1 by tan theta. So resistance is actually, if v versus I graph is given, then resistance is actually inverse of the slope. Okay, so for here it is given theta is 45 degree for one and theta is 30 degree for the another. Right, these are the two values given here, 30 degrees and 45 degrees. So what are the corresponding resistances? So R1 equals to 1 by tan 45. It is easy to calculate, which is 1 by 1, that is 1 ohm, and R2 equals to 1 by tan 30. Now tan 30 is 1 by root 2, 1 by root 3. So 1 by tan 3 will be 1 by root 3. So that is root 3, that is 1.71 ohm. Okay, so these are the two values of the resistances. Now values of the resistances are calculated. Now we will go back and use our formula to calculate alpha. Now remember, smaller resistance obviously denotes smaller temperature. Higher resistance always denotes higher temperature. If you still confused, just calculate the resistances using the given data and then figure out which represents which temperature. Alpha is difference in the resistances divided by inverse order RT1 T2 minus RT2 T1. Okay, RT2 is this one 400. For 400 it will be 1.71 minus 1 divided by 1 into 400 minus 1.71 into 100. Okay, now let's simplify. It will be 0.71 divided by 400 minus 171. So it will be 30, 200, 230. So 0.71 by 230. Okay, approximately you can consider these values. Let's say 71 into 10 to the power minus 2 divided by 230. Now if you take this 230 closer to 250 and 71 closer to 75, okay, so basically we have increased both sides a little bit. Okay, so for that we can calculate it. It will be 75 3 is 25 3 is 75 and 25 1s are 250. So it will be 10 by 3, 3 by 10. So it will be approximately value will be 3 upon 10 into 10 to the power minus 2, or it will be 3 into 10 to the power minus 3. Approximate value, obviously we have to check the options. So 3 into 10 to the power minus 3, again even our approximated value is coming out to be very correct. So correct answer is option A. If you calculate it, I'm not sure what will be the exact value, but it will be very close to 3. So approximation is very important when you are solving any questions in KCET exam. Okay, approximation is super duper important when you are solving any questions in KCET exam. Okay, that gives you an idea what could be the possible answer. So what we have done here, 71, 230 both are, you can find out a figure between them, but if we take 71 to be close to 75 and 230 close to 250, then our results is actually matching. End up ourselves RBC or pace if we start from today with full dedication. Yes, Chandan. Chandra, why not? So if you are starting with full dedication, see, instead of asking, I always tell you that instead of asking the question, you should always start first, then you ask that I have started today. Instead of saying that if I start, I have started today, will I be able to get RBC? That question you should ask. I always appreciate if you say that I have started today, I am starting today, will I be getting the college? If you say that if I start today, this day will never come. Every day you will come and say, sir, if I start today, if I start today, if I start today. So that day will not come. You should tell that I am starting today, I have started today, will I be getting the college? Right? That should be your answer, not like if I start today. There is no if and but, you have to start today. Right? There is no ifs and but, you have to start today at any cost. then only you will be able to successful. If you say that if I start, that if will remain if only. So I have started, okay, I am starting. If you can answer that, then only it is possible. If you say if I start, that if is not going to happen any day, right? Now question number 16. An electric bulb of 60 watt 120 volt is to be connected to a 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? So here we have a bulb, okay, which is connected to some battery. The power rating of the bulb is 60 watt 120 volt. This is the resistance and the supply voltage is 220 volt. Okay, so few things that you have to remember. The bulb requires only 120 volt out of the 220 volt supplied, right? So 220 volt you supplied, 120 volt is utilized by the bulb. So what happens to the remaining voltage? The remaining voltage must be deposited across the resistor. The remaining voltage must be absorbed by the resistor. That means the resistor will have a voltage of 100 volt across it. So this is the conservation of energy. So total voltage, whatever voltage that you supply, has to be distributed amongst the components. Okay, and if you want the bulb to function properly, then obviously the bulb will only be taking 120 volt. Remaining 100 volt should be taken by the unknown resistor. Okay, this resistance's value we have to find out so that it assumes it absorbs the remaining 100 volt. Now what? This much is clear. Now power rating of the bulb is given, voltage rating of the bulb is given. So you know that P equals to voltage into current. Power is Vodafone Idea. So power is given 60 watt, voltage for the bulb is 120 volt. So what is the current that must be passing through the bulb? The current that is passing through the bulb must be equals to 60 upon 120. Almost same question came in 2026 as well. Almost same question came in 2026 as well. So if you see that same data, just slight change in the question is being asked repeatedly in KCET. That's why solving PYQs are super duper important when you are preparing for KCET. So half ampere is the current. Half ampere is the current. Now current we have calculated. Now we know that the bulb and resistances, both of them are connected in series. In series combination, current remains same. So whatever current is passing through the bulb, same current should pass through the resistor as well. That means resistor should also have the same current I as well. That means what is the voltage drop across the resistor? Voltage drop across the resistor is, according to Ohm's law, V is equal to IR, and according to our calculation, this should be also equals to 100 volt. Okay, current is half ampere, so half into R is equals to 100 volt. So R should be 2 into 100, that is 200 ohm. Okay, so for the bulb to function properly, the unknown resistance must be 200 ohm, right? Nimappa, so there are two questions. One is from Rama, another one is from Nimappa. So first Rama's question. KCET PYQs are not enough, but they are, you cannot skip them. It is not enough, but it is almost 70% of your KCET preparation. Obviously you need to know the theory, you need to know certain concepts, okay, because but yes, KCET PYQ should be 70% of your preparation alone. Okay, remaining 30% theories, concept, okay, few ideas, how to approach a question, some skill development, they are there. But otherwise, if you want exact, for example, the similar question, only thing that was asked was number of charges. Okay, number of charge based questions also being asked. Now if you consider, if you have solved all the previous year papers and appear 2026 exam, then you would be also able to solve that question. It is not a single question that is repeated. If you combine 2-3 questions based on the concepts of 2-3 questions, now there was one question, right? So exact question do not repeat in PYQs, but PYQs, understanding the PYQs, and obviously to understand PYQs you need to study the theories, you have to understand the concepts as well. So obviously PYQs are 70%, and along with the PYQ practice you also have to practice some new fresh questions, so that whether you are able to apply your ideas, your learnings on those questions or not, that is also important, right? Because PYQs you practice 2-3 times every questions, maybe you memorize, you have a very sharp brain. I know some of the students in my classes, when I used to teach in the classes, they memorized all the questions. If you repeat one single question from the questions that I have taught in the class, even if it is difficult, they will memorize the answer and they will write the answer. Okay, and some students came to me and saying that, sir, please do not repeat any questions that you have taught in our class, because all there are some students, they memorize all the answers and they get out. Actually, there is no, that is also talent, but in exam exactly same questions will not come. So you have to practice new questions, so that you are able to apply the knowledge that you are gaining from solving the PYQs. So PYQs are 70% of your preparation, but yes, there are other things that also you have to study. Secondly, Nimappa, just contact your college. I am not sure about the board improvement exam. If you are hospitalized before your exam, and if you have qualified class 12th, obviously if you have just barely qualified your 12th exam, then obviously you are not in a good position, because KCET exam do consider the 12th marks. 50% of your KCET results is dependent on 12th marks. So do consult with your college and check what is the possibility of improvement of your 12th board results. Okay, generally they allow, if you have failed in both exams this year, then you will be allowed to take the test in upcoming year. Okay, but because you have passed, so that is a different situation for you. You go into your college, inquire about what is the process as to appear for the exam for 2027. Okay, but yes, remember, always try to prepare well for your board exam. Board exams do count 50% of the marks directly calculated for your KCET ranking. If you have only so basically, Rama, there are two ways I generally recommend. First, you try to, for example, I am solving the questions. You observe it, okay, how the questions are being solved, and then you try to solve those PYQs once more on your own without looking at the solutions. Okay, so first time if you just approach the PYQs at raw, maybe 10% of the questions you will be able to solve. Okay, because PYQs also, not all the PYQs are same, not all the PYQs are easy. So just I will recommend you to watch or check once at least how the questions are being solved, and then try to solve it on your own once. Okay, then you will get an idea, okay, whether even after learning the theory, even after learning the tricks and learning the process of solving it, whether I am able to repeat that or not. So when you are doing it, do it honestly, and if you are doing it honestly, you will get an idea about yourself. So I have initially, if you just approach, try yourself only. You take one chapter, okay, first 3 this is the 3rd chapter that I am doing it in our channel. So take any one of the first 3 chapters, try to solve all the PYQs on your own. Okay, see how many of them you are able to solve it. Then next chapter, chapter number 2, you watch my video, the way I have solved it. Now you try to solve them once more and see how many of them you are able to solve them properly. Okay, so then you compare. Okay, in the first place, when I have just gone raw, I was only able to solve, say, 5 questions, 10 questions. When I have watched the video, then I am able to solve, say, 20 questions or 25 questions. That means you have an improvement. So that improvement is required, and based on that you should decide, okay, whether I should approach raw. If you are doing well in the raw sense without watching anything, you just have the theory knowledge, you are solving the questions and you are solving 20-25 questions for last out of 30 questions, then well and good. Okay, but if you are struggling without assistance, you are not able to solve many questions, then I recommend you should check at least one or two once videos, or if you don't want to watch my videos, that is also fine. You check the solutions in the given in the books, but solutions given in the books can be sometimes little bit tricky, because they just mention the formulas without proper explanation of the equations, etc. So that I feel that some students find it difficult. Okay, that's why they come to our lectures, they watch our videos where we have explained everything in detail. So based on your own experience, you can take decisions. But for me, if you ask me, I will recommend watch the lecture once and then try to solve them on your own without looking into the solution. Okay, this way you will be able to learn faster. That is a way of learning faster. Whatever methods, tricks I am teaching it, how many of those tricks, how many of those shortcuts you are able to apply in the paper. So that is one very important point, important thing to test. Right, now let's move on with our discussion for the next question. Okay, I think I have solved it. Yes. Yes, Nimappa, you can send your mark sheet, but if you are applying as a fresh candidate, or if you are applying for improvement, okay, that will automatically be updated in the system, because you have to, if you are a Karnataka board student, you are your SATs number has to be uploaded in the system, right? So the system will automatically fetch your latest results. So your old results will be scrapped as soon as you get an improvement result. For example, someone appeared in the first exam, in the next test, whenever they are getting the next test, okay, improvement result 2, okay, the first result is automatically scrapped, the second results will take its place. Okay, and in some cases, I think if the result is lower than the previous one, the first one stays. Okay, if the final result is lower than the first one, then first one stays, best of two, right? But in Karnataka government, they have given 2 years, either improvement or clear the exams. So that is the 2 years given to you. So this year you can, but yeah, I think if you are appearing for the exam, you have to appear for all subjects, if I am not wrong. So try check with your college. But yes, once your new results are coming, the new results will only be considered. The old results will be scrapped. So when you fetch the result using your using the app, I forgot the name, DigiLocker. So when you fetch the result from DigiLocker, it is not that you have to upload your results. You have to fetch the result from the DigiLocker app, and your latest results will be there. So from there you can fetch your latest results, right? Okay, Nimappa, I hope that helps. For a given electric current, the drift velocity of conduction electrons in a copper wire is Vd, and their mobility is mu. When the current is increased at constant temperature, Vd remains the same, mu increases, Vd decreases, mu remains the same. Vd remains the same, mu decreases, Vd increases, mu remains the same. So, mobility of a conductor depends only on its temperature. Okay, mobility of the conductor depends on its relaxation time, and relaxation time is basically dependent on the temperature. Okay, so mobility is a constant quantity. Okay, so if you increase the current, okay, then NEAVD, okay, so Vd is drift velocity. Now number density is constant, charge of an electron is constant, area is constant. So if you increase I, Vd should increase. Now mobility is given by Vd upon electric field, drift velocity per electric field. Now when you are increasing the current, how can you increase the current? The only way to increase the current by increasing the electric field. Okay, so electrons are experiencing greater force, they are moving faster, etc. So drift velocity is also increasing, electric field is also increasing, but mu remains constant. Mu depends only on the temperature. Mu depends only on the temperature. Mobility depends on temperature and the material itself. So here material is same. Okay, current is increasing, so drift velocity increases, conductivity remains same, mobility remains same. So Vd increases, mu remains same. This is a theoretical question. Again, if you are confused, you have to analyze this kind of questions. If you are not confused, then you can directly approach the question. Okay. Now, next is 10 identical cells, each of EMF 2 volt and internal resistance 1 ohm, are connected in series with 2 cells wrongly connected. So, how many cells are there? 10 identical cells. What is the voltage? Each have 2 volt, internal resistance 1 ohm. Okay, a resistor of 10 ohm is connected to the combination. What is the current through the resistor? Let us understand this diagram carefully. So, here we have 10 cells. 10 cells means like this. But there are total 10 number of cells. Out of this 10 number of cells, 2 cells are wrongly connected. What is the meaning of wrongly connected? Wrongly connected means they are connected in reverse. Okay, they are connected in reverse. Okay, so if everything is positive, negative, suppose the order is positive, negative, positive, negative, positive, negative, this will be negative, positive, negative, positive, negative, positive. So the order of the cells are different. That is the meaning of wrongly connected. Now this entire system is now connected with a external resistance of R, which is given by 10 ohm. Okay, R is given by 10 ohm. So 10 ohm resistance, external resistance. Now they are saying that what is the current through this resistor. So what is the current that is flowing through the resistor? How to solve it? First of all, what is the total EMF or equivalent EMF? So equivalent EMF, how many cells were there? Cells were 10. Out of them, how many were properly connected? 8 were properly connected, right? 10 minus 2, 8 were properly connected. And what is the EMF of all those 8? So 8 into 2. This is the correct connection. Now 2 of them are improperly connected, reverse connected. So that is sending a voltage in the opposite direction. So what is that voltage? 2 into 2. 2 of them are improperly connected. So what is the equivalent EMF? All of them are in series. So no need to worry. 16 minus 4, that is 12 volt. 12 volt is actually the equivalent EMF. Now what about the total resistance of the circuit? Total internal resistance. Total internal resistance. Now no matter how the cells are connected, internal resistance always gets added. Internal resistance always gets added. So total internal resistance will be 10 into small r, 10 into I think 1 ohm, that is 10 ohm. So 10 ohm is the equivalent resistance of this resistor, of the cells. So total resistance of the circuit, is R plus R equivalent, that is 10 plus 10, that is 20 ampere. 20 ohm. So what is the current in the circuit? Current in the circuit is equivalent EMF by equivalent resistance. So equivalent EMF is 12 volt and equivalent resistance is 20. So it will be 6 by 10 or 0.6 ampere. So it will be 0.6 ampere. Okay, interesting question, unique question. But if you know the steps, if you understand the process, you should be able to solve it. Not a difficult mathematically. Now, this is a very important question. This is a very trick question. If you only know the trick, then only you will be able to solve similar questions. Okay, so here it is saying the equivalent resistance between points A and B in the following circuit. So equivalent resistance between A and B in the following circuit. Now if you see the circuit is not ending, it is dot 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 dot. What is the meaning of that? It is an infinite circuit. This is an infinite circuit. So in the infinite circuit, how to find the equivalent resistance, which is very important to understand. So basically, suppose we have a infinite circuit like this. Let me redraw it so that I can show you what I am trying to say. So this is the circuit, right? Now, in case of infinite circuit, you have to find a point where if you remove it, suppose if I remove this portion, okay, and because it's an infinite circuit, I can draw another section over here and I can continue dot dot dot, right? This is an infinite circuit, so the same pattern repeats, this pattern repeats at each and every point. So if I cut and remove it, this portion, okay, which is kept over here, so this portion is cut from this circuit and separated. So now if you look into this portion, this also looks exactly the same as this one, right? This also looks exactly the same as this one, right? No change. But still we have cut from here and removed it, but we have added one more branch over here because it's an infinite sequence, right? The same sequence will repeat at each and every junction. So if we add one more junction over here, and even if we cut it, it will still looks like the same as the original circuit. So if the original circuit has an equivalent resistance of capital R, okay, if the original circuit has an equivalent resistance of capital R, then this portion, this infinite portion, should also have the equivalent resistance capital R, even if we have cut one portion out of it, because it looks exactly the same. So if it looks exactly the same, this is also infinity. If you take one bucket of water out of the ocean's water does not reduce, right? Because it's infinite source of water, okay, theoretically. Similarly, if you cut one portion out of an infinite circuit, it does not change the overall resistance, as long as the design looks exactly the same. Okay, if you just cut one resistor out of it, the design does not look same. Even if you cut two resistor out of it, the circuit does not look same. So you have to find the symmetric point where if you cut it, okay, for example, this is the pattern that is repeating at each and every point. So even if you remove one such junction, the overall resistance of the circuit does not change. So if this one has a resistance R, this one will also have a resistance R. So why we are stressing on that? Because we know that with this portion on, this will also have a resistance R. Now what we have done, we first cut this portion, we removed this portion, and we say that equivalent resistance of this one is also R. So we say, okay, now let us remove this entire portion and bring back our original cutout. Original cutout was this, that we have cut it from the circuit, okay, and this portion will also have a resistance R. So that portion we can connect it like this, right? Because we crossed over here and here. So our cutting point was here and here, and we said that this remaining portion should also have resistance R. So after doing that, we can basically replace this cutting point with a resistance capital R. Okay, this is 2, this is 2, this is 2. Now this is our original circuit. So our original circuit is reduced to this. So you have to find a point where if you cut, the circuit looks exactly same, and you say that the exactly same portion will also have the same resistance at the original circuit. That means we can replace it, and now this is our original circuit. Original circuit also have a resistance R. So equivalent resistance of this one is also R. That is the trick that you need to know. Little bit higher level obviously, but if you understand this once, then similar questions will be very easy for you. Find the symmetry point, which pattern is repeating again and again, take the minimum portion of it, cut it out, okay, say that this is the pattern which is repeating. So the total resistance of the circuit is R. The repeating pattern should also have the resistance R, because it's an infinite circuit, then only it is possible. Okay, and then you add that R over here and say that this combination will also have a resistance R. Now we have to simplify it and solve it. Okay, Now how to solve it? So these 2 and R are connected in parallel. So these 2 are parallel. So 2R divided by 2R divided by 2 plus R. So this is parallel combination. So you place this one using this one. Okay, this is 2R by 2 plus R, right? Now these 3 are in series, so you have to just add these two. So you get 4 plus 2R by 2R. So this is the equivalent resistance of this circuit, and according to our assumption, this should be equals to the original resistance R, that is the circuit total resistance of the circuit. Now you have to simplify this equation. If you can simplify it, your life is done. So 8R plus 2R equals to, I think I made some mistake over here. This is 2 plus R, sorry, equals to R. Okay, so 4 into 2 plus R plus 2R divided by 2 plus R equals to R. Okay, so 8 plus 4R plus 2R equals to R into 2 plus R. So it will be 8 plus 6R equals to 2R plus R square. Okay, so it will be now take this on the other side, we get R square plus 2R minus 6R minus 8 equals to 0. Okay, so we get R square minus 4R minus 8 equals to 0. Okay, now this is obviously not a directly solvable equation. You have to use quadratic roots of this equation, and if you use the quadratic roots, R will be coming out to be 5.5 ohm. Okay, R will be minus B plus or minus. Now plus or minus, we will not take the minus value, resistance cannot be negative. Okay, B square minus B square minus 4AC. So B square is 4 square minus 4AC divided by 2. Okay, so it will be 8 plus 16 minus 32 by 2. Okay, 16 plus 32, sorry, minus plus. So it will be 8 plus square root of 48 by 2. Okay, obviously it cannot be directly calculated, but yes, it will be 4. Okay, let me do the 48 part as well. 48 is 8 plus 4 root 3 by 2. So it will be 4 plus 2 root 3. Okay, so 4 plus 2 root 3, which will come out to be 5.5 ohm. Okay, I think I made some mistake in the calculation. Yes, one mistake I made. I make a mistake, it will be 4 only. Why it is 8? It will be 4. Okay, and it will be 4. It will be 4 by plus 4 root 3. So it will be coming out to be 2 plus 2 root 3. 2 plus 2 root 3, if you put the value of root 3 as 1.7, you will get it as 5.4. Okay, if you take exact value of root 3, it will be 5.5 ohm. Okay, this is little complicated, tricky. The calculation wise it is tricky, but if you understand the theory, it can be solved in 2-3 minutes in the exam hall situation as well. Okay, even in the exam hall situation, if you are if you know how to apply the concept, because it took a lot of time for me to explain the concept, that you cut it, you add it back, and with the equivalent resistance, and then simplify it. That's why it took some time. But if you know that this is the trick that I have to apply, then only mathematical part is there, and mathematical part, this quadratic equation, you are more used to than me, because obviously I personally do not use quadratic equation too often. Okay, you can solve it much faster than me. Okay, now let's move on with the next question. A wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance small r. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. So, when the current is being flowing in a circuit, okay, and there is an external resistance R, the work done by the battery to establish the current is always given by the energy, that is I square RT. This is the work done by the battery to establish the current. This is the energy that is being used in the what should I say, in the resistor, external resistor, internal resistor, whatever is there, that part is actually getting wasted. The actual effective work done to establish the current is I square R T. Okay, it will be I square R T. Now next, 10 identical cells, each of potential E and internal resistance R, are connected in series to form a closed circuit. So another similar question. Okay, are connected in series to form a closed circuit. An ideal voltmeter is connected across 3 cells. What the cell will read? So here we do not have any external resistance, we only have internal resistance, and we have 10 such cells, and they are connected in series. Okay, okay, so they are connected in series in a closed loop. Total 10 cells are there. Now out of that you have taken 3 cells, and you are trying to find what is the voltage across these 3 cells. Now here, how to solve these kind of questions? So here, first step is to find the current in the circuit. What is the current in the circuit? So how many cells are there? Total 10 cells. So equivalent EMF will be 10E. None of them are wrongly connected, all of them are properly connected. That means equivalent EMF is 10E. What is the equivalent resistance? Equivalent resistance will be 10R. So what is the current? Current is voltage by resistance, that is 10E, by 10R, that is E by R. Okay, now when you connect a voltage, a voltmeter, ideal voltmeter do not know about anything about battery or not. It only sees there are some resistance, and through the resistance how much current is being going, and based on that it measures the voltage. So when you connect across 3 cells, it only sees these 3 resistors. Okay, these 3 internal resistors. So what is the voltage you will measure? The voltage you will measure is basically the total current into the total resistance. Okay, total resistance here is 3R. Okay, 3 of them are there, 3R plus R plus R. So this will be measured by the voltmeter. It will not know anything about the cells. Okay, current is given by E upon R, and the resistance is 3R. So it will measure only 3E. Now, so the EMF will be 3E only. Do not randomly or guess the answer less than 3. It will be 3E only. The specific reason being here, no external resistance is added. If external resistance is added, then some current is being wasted through the batteries, through the resistors. Otherwise, it is actually not getting wasted. You will get the full EMF out of the battery. Okay, you will get full EMF out of the battery. Next question. In an atom, electron revolve around the nucleus along the path of radius 0.72 angstrom, making 9.4 into 10 to the power 18 revolutions per second. The equivalent current is. Okay, so now here it is the electron which is orbiting around the nucleus. Okay, now when the electron is orbiting, what is the current? Now this radius etc, these are extra information, you can skip this information. Radius is in case of current electricity, radius of the orbit is not required. Only whenever an electron or charged particle is rotating in a circular path, the thing that you have to measure is that in 1 second how many rotation it is doing. In 1 second how many rotation it is doing. Each rotation refers to one electron equivalent of charge. Okay, suppose in 1 second it is making, say, n number of rotations. So total charge that is passing through the conductor in 1 second will be n into E. That's it. And current will be charge by time. Now time is 1 second you have calculated, so it will be n. So you basically you have to find the number of rotation that it is doing in every second. Okay, here it is mentioned that 9.4 into 10 to the power 18 revolutions per second. That means the number of rotation per second is 9.4 into 10 to the power of 18. So this is the number of revolution per second. That means each revolution, one single revolution, electron is passing only once. So 2 revolution, electron is passing twice. 3 revolution, electron is passing 3 times. Here these many revolutions, electrons is passing these many times. So what is the total charge per second? Total charge plus per second is n into E, and current is obviously charge by time, that is Q upon 1. So 1 second is mentioned, so only you need to calculate I is equal to NE, which is 9.4 into 10 to the power of 18 into 1.6 into 10 to the power of minus 19. Okay, if you take 9.4, now this multiplication can be tricky if you are not familiar. So 9.4 into 1.6, how can, and if you see the values are also close. So even if you take some approximated value, it may be slightly wrong, but yes, there are few ways to approximate that as well. But anyway, let's simplify. 94 into 16, obviously 2 decimals are here. So 4 6 are 24, in hand we have 2, 54, 56, okay, 94. So use the old school method if you are running out of option. If you see that all the options are very close, do not approximate. If the results are far apart, then you can approximate and get a correct answer. But if the results are very close to each other, do not approximate. Okay, so 4, then we have 0, in hand we have 1, okay, then 14, 15. So, and how many decimals? 1 2 decimals, 1 2 decimals. So 15.04 into 10 to the power of minus 1 plus 18 minus 19 minus 1, so it will be 1.5 ampere. So the current passing through the conductor is current passing equivalent current is 1.5 ampere. Okay, so this is the only way to solve such question. If the options are very very far apart, okay, suppose 1.4 1.8 was not there, then you could have taken 9.4 to be very close to 10 and multiply it with 1.6, and you say this is 1.6. The answer should be very close to 1.6 but smaller than that, then you take 15 as your answer. But here 1.4 could also be correct answer, which is also very close to 1.6. So do not make that approximation for this kind of particular cases. Okay, approximation is good when you have options far apart. Okay, so suppose 2, 3, 5, 1.5, 0.5 is given, you can use the approximation method that I have told you. The variation of terminal potential difference with current flowing through a cell is as shown. The EMF and internal resistance of the shell is. So here it is the terminal voltage and current graph is given. Now if you see here, at this point the current is 0. So at this point current is 0, and at this point the terminal voltage is 0. Okay, you have to find EMF and internal resistance. Now for that we will basically using a very simple formula, V is equal to EMF minus I into R. Okay, EMF is equal to I into R. We will apply the both conditions here and here as well. For this point current is 0. So V equals to E. Okay, because I equals to 0. Okay, so I is equal to 0, and if you see what is the terminal voltage is 3. So 3 is equal to E. So EMF of the cell is 3. Okay. Next, we will be using this point where terminal voltage is 0. So terminal voltage is 0 means 0 equals to E minus IR. Okay, obviously terminal voltage is 0. Okay, now you get R equals to E upon I. E is 3. Here current I is 6 ampere. So current will be 6. So that will be 0.5 ampere. Okay, so correct answer is 3 volt 0.5 ampere. 3 volt 0.5 ohm. 3 volt 0.5 ohm. So correct answer is option D. Next question. A charged particle is moving in an electric field of 3 into 10 to the power of minus 10 volt per meter with mobility 2.5 into 10 to the power of 6 meters square per volt second. Its drift velocity. Electric field is given, mobility is given. They are asking drift velocity. Mobility is given by drift velocity per unit electric field, that is Vd upon E. So Vd equals to mu into E. So mu is given 2.5 into 10 to the power 6 and electric field is given 3 into 10 to the power minus 10. So it will be 7.5 into 10 to the power minus 4. 7.5 into 10 to the power minus 4. So option B is correct answer. Easy question, easy solution. Last question of the day. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease. Okay, so the question is about the voltage rating is given. Okay, and it is mentioned that voltage is dropping by 2.5%. Then what would happen to the power? Okay, so how to solve such questions? You have to remember power. So only voltage is decreasing. Okay, only voltage is decreasing, and based on that you have to figure out how to solve it. Current, any information about current is not given, so you cannot use the equation related to current. So power equals to V square R. This equation will be using. Resistance is constant for a given conductor. So if power decreases, voltage will decrease. That's normal. If voltage decreases, power will decrease. That's what the question is asking about. Power is voltage is decreasing. How much power will change? Now, how to do that? Some values are given. So initial power, final power, find the difference, find the percentage. No. So if you remember, there was a process in your first unit, first chapter, units and measurement. We have briefly touched it, called error analysis. In case of error analysis, when multiple variables are involved, we do it like this. So if you differentiate both sides, okay, you get 2v dv. Okay, 2v dv. Okay, and r is a constant, so it will be remaining as constant. So this is the differential relation. Now what we will be doing, after doing it, we divide both side with the constant, with the power p. So on our left hand side we get dp by p. On our right hand side we get v dv into r divided by p. Now p is equal to v square r. So we substitute that over here. R cancels. One of the v will cancel and we get 2 into dv upon v. Now dv upon v represents percentage change or in normal change. If you multiply it with 100 and create it, you will get the percentage change. Okay, and if you don't do it, small fractional change, also represented by this. Because we are finding the percentage change on both sides, so it does not matter whether you are doing percentage change or not. Okay, but this represents the change in one quantity. So here 2.5%. So dv by v is 2.5%. Okay, dv by v is given in this question as 2.5%. So just substitute in this equation, you get dp by p equals to 2 into 2.5%, that is 5%. So change in the power will be 5%. Change in the power will be 5%. Again, this is a unique question, never repeated in our upcoming year, and very good question in my opinion, right? Saraswati is saying easy. Which question you are saying, Saraswati? This question or previous one? This is not, I think you are saying the previous one. Yes, previous one was easy. Previous one is easy. So in KCET exam, not all the questions are equal. Okay, obviously, like the fingers of your hand. Okay, not all fingers of same size. So there are some fingers which are little longer, some are shorter, some are thicker, right? So in KCET also same like that. Some are easy, some are shorter, some require some extra time even though they are easy. Okay, some questions are difficult, right? So all the mix is KCET exam. Now, before I just conclude my session, just wanted to show you once more about our free YouTube batch. Okay, and you can study from us without any distraction. You just visit the description of this video, click on read more, click on the join free AS KCET 2027 course. It is free absolutely. Once you click on this link, you will be redirected to this page, and once you come over here, you will see that this is available for absolutely 0 rupees. This is free YouTube batch, free course, and you will learn it from our platform, so that you will get the support of our platform. Click on the buy now, register yourself first time. Okay, once you have registered, you just need to enter your mobile number and the OTP, and you will be redirected to our page over here. Okay, you will be redirected to our page over here, and you will see the course. So once you click on the course, continue, you will get physics, biology and mathematics. Here chemistry will be added very soon. So click over here, and you click on the chapter. All the lectures that are done for your physics PU2 as well as KCET will be populated over here, including today's live will also be populated over here. You will get the class notes from this platform. You will get the assignments also, chapter wise, topic wise. All the assignments will be added over here as well. And once you are downloading the PDF, it is absolutely for yours to use. And all subjects, all lectures, quiz. Okay, there will be quizzes over here, there will be assignments over here, there will be class notes will be available here as well. So everything will be available, and more important part is there is no distraction such as YouTube. In YouTube, there will be some videos coming on your left, some videos coming on your right. But if you watch the same video from here, okay, click on play, there is no distraction. Only the video will be played over here. Even you can change the speed if you want to study a little bit faster. That is also possible from there, right? And you can ask doubts here as well. Okay, you can so you can get a doubt as well over here. Okay, and everything is free of cost. You don't need to pay anything for it, right? Because I am just asking it here. So it is also answered based on the image. Teacher is explaining revision session of second PUC physics. So everything, the way the AI support will also be there. So don't worry. And this is absolutely free of cost. Register yourself. Click on the link given in the description section of this video and register yourself now to get access to this free YouTube batch by Vedantu. Right? I'll be back. If you have any other questions, any other doubts, please leave a comment in the comment section. And if you have not yet subscribed, don't forget to subscribe to our channel. Right? I will be very happy to see you coming to our classes regularly, because regularity is very important. And if you want to be a regular student of our YouTube batch, definitely you have to come regularly, right? That will help you to improve on your scores as well, right? So this is the end of this session, almost 2-hour session, 2.5-hour session, no, 2-hour session, sorry. So 2-hour session. I will be back with another session very soon. Till then, bye.